So today my presentation is going to be based off of our first experiment, which was what's in the water. So what is the purpose of this experiment? So the purpose of this experiment is to find the IR, which is the functional groups, and the NMR, which is the number of hydrogen peaks for your given unknown. So mine unknown was vial 17, and vial 17 needs to be ran through the IR and NMR machines in order to determine what type of functional groups it has and what's the ratio of hydrogen peaks it has. And this is a procedure given by the Department of Chemistry and Biochemistry. In vial 17, through the series of experiments, was determined to be 2-propanol. So what is IR? So IR, or infrared spectroscopy, deals with the infrared region of the electromagnetic spectrum. And according to Libre text chemistry, so IR spectroscopy measures the vibrations of atoms, and based off of these vibrations, it is able to be determined what type of functional group the compound has. In table 1.1 shows the absorption peaks and the different characteristics of absorptions through IR. This is the range of absorptions, and these are the functional groups. In the H on the benzene ring and H on the singly bonded carbon is to help differentiate CH and CH. So what is NMR? So NMR, or nuclear magnetic resonance, is an instrument that allows a molecule structure to be analyzed through its interaction of nuclear spins when it's placed into a powerful magnetic field, and that's according to J-Lo. And right here is a little graph that shows you how the hydrogen peaks works and how to find the ratio from each hydrogen peak. So why are Lewis structures important for this experiment? So figure 1.1 shows a bunch of different compounds and its Lewis structures. And these are important because each compound will help you find the functional group for IR spectroscopy that needs to be implemented into a table that will help you determine what type of compound your unknown is going to be. And Lewis structures are also needed to solve the number of hydrogen peaks in NMR. And this one circled right here, that is the structure of 2-propanol. So you're gonna take your little vial, and you're gonna take a pipette, and you're gonna gently squeeze out a couple drops of liquid. Then you're gonna take a little brass and you're gonna place it onto the diamond of the Thermo Scientific Nicolette IS5. And then you're gonna squeeze a couple droplets into the center of the brass so it lays right on top of the diamond. Then the IR machine will then scan the liquid and input this data into a computer that will turn it into a graph, which will show the different types of peaks and the numbers of each peak that correlates with a certain functional group of that compound. Then the vial is going to be placed into the Asensi instrument EFT90, and that is the NMR machine. And you're going to wipe down your vial before you put it into the machine because finger oils will mess with how the experiment's going to work. Then you're going to place it into a height block to get the certain height that you needed. Then you're going to gently place it into the machine where it then will be spun around. Then data will be collected, then implemented into a computer, which will also make a graph and show you the different hydrogen peaks and the ratio that each hydrogen peak has. And the results. So these are both table 1.2 and table 1.3 were both found based off of the Lewis structure. Table 1.2 shows the different molecules in relation to their functional groups. So this is an infrared spectroscopy one. Then table 1.3 shows the number of hydrogen peaks and ratios of each given molecule. And this is the NMR spectroscopy. And 2-propanol had a OH bond and a CH singly bonded carbon. Then it also had 3 hydrogen peaks and a ratio of 6:1:1. And these are the scans. This is the IR scan of vial 17. And this is the NMR scan of vial 17. As you can see, the NMR scan shows 3 different peaks. And each one is labeled that has a 1:1:6 ratio. Then these are the results based off of the IR and NMR graph. So table 1.4 shows the NMR spectra of the unknown compounds, and vial 17, based off of graph 1.2, showed that there was 3 peaks and it had a ratio of 6 to 1 to 1. Then 1.5 shows the infrared spectra of the compounds, and vial 17 had an OH bond in a CH singly bonded carbon. And table 1.6 shows the identifications of the unknowns, and based off the information from the graphs. In tables 1.2 and 1.3, vial 17 was revealed to be 2-propanol. And because vial 17 was revealed to be 2-propanol throughout the scans, it was showed that it had a CH bond and a OH bond. In the NMR showed that it had 3 peaks in a 6 to 1 to 1 ratio. And 2-propanol, according to the UF Research Service Centers, states that the vapor is very harmful when either ingested or inhaled. And the compound also has the ability to be absorbed through the skin. So it usually causes like eye irritation. It can cause death, dizziness, drowsiness. So it's very important to stay clear or use it responsibly. And the chemical is toxic to the environment because it releases carbon monoxide and carbon dioxide, which are very dangerous gases. And because these get released into the air, and it makes it very dangerous for it to be sitting on top of surface water in the environment, because it can kill people who ever come upon it, or it can kill like animals and maybe in some cases plants as well. And this shows you the dangers and how to prevent some of these. And this shows you the responses if you inhale it, if it gets in the eyes, or in case it causes a fire.